All right, good morning. So I'm going to start off with module 4, which was the auditing encryption module, because module 12 is an extension of the auditing feature, so it makes a lot more sense to talk about this part, which is first principles, and then get into the more complex variety of it. When we're done module 4, we'll bust into labs, and then we'll see where you're at when we're done, and we'll see how much of the next module we can complete. Rob, share. Please bear with me here. Bring that up. Share the PowerPoints. There we go. Let me slide this up a bit so I can see what's going on. Right, so 2 topics. Auditing and encryption. We start off with auditing, we end with encryption. We have options for configuring the auditing at various levels. You recall the concept of auditing back from Windows Server. You can turn auditing on in Windows Server, say, for example, for a file folder, and whenever somebody goes in and does something to it, you have a log entry somewhere. Same kind of idea, but here we are tracking and tracing and recording access and data changes for SQL-related items, which could be at the full-on server level, so who's doing what to the whole server, but you can go inside, right, into deeper levels, who's doing something to an instance, who's doing something to a database, who's doing something to a table, and then other features you can put in place that will allow you to perhaps catch an exchange, an interaction that you didn't like, and you want to return the data back to its previous form because it was somebody potentially doing something malicious, right, or foolish. So therefore, there's a way to have like a history table that keeps track of stuff. We'll talk about that, how to implement it, again, with the GUI or with SQL commands if you want, how to manage these things, and then the final topic, how can you lock your data down using encryption? And there's a few options there that will allow you to either just lock data down at rest when it's sitting on the hard drive, or actually encrypt data on the fly, so even when it's in transit, it's also secure. These features of SQL Server encrypting data, right, can be used complementary with our other things, right, such as SSL encryption for web transactions. So defense in depth, right? You have some SQL features that's encrypting your data, but at the same time you have an SSL pipe for your web server that's encrypting all web traffic, and bam, right, defense in depth. First chunk, we'll talk about data access. Common compliance. So back in CYSA, hands-on ethical hacking stuff, we talked about GDRP, right, being compliant with that. So, and recall with GDRP, a big part of that was restricting access to personally identifiable information, right? Anonymity for users, having chunks of data removed that didn't have the person's real name in it, just re-expressing it with some obscure code. Well, there's other compliances besides that. So we're going to talk about how you can turn that feature on your SQL Server. And the author tells us a lot of these features you can turn on, but remember, there's always a trade-off between access and security. So as soon as you start adding more security features, things are going to slow down. So you may not be able to turn everything on, right? You're going to have to make sure that if auditing and compliance is a requirement, you are looking after those things that you have to and not everything. And also you may have to beef up your server that you're on, more memory, more CPU, faster bandwidth, solid state drives, so that you can actually keep up with all this extra work of auditing and being compliant and whatnot. Now we're going to talk about triggers. So how does auditing work? Something happens, an event. If you are watching for that particular event, and that event fires and you're auditing it, that is effectively a trigger. And what does a trigger do? It says, oh, one of these things happened. It's a logon. Boss says to audit logons. Your trigger will fire, and that will go and do the action you want it to do, which may be, writing an entry into a SQL Server log file, writing an entry into the event viewer logs, which is an option, writing an entry into another table in your database so you can keep track of historical, or as they like to say here, temporal information. So there's auditing with temporal tables, history tables. And then I got a few demos in here where I'll run through some of the features. And why do we have auditing? for security purposes and for compliance purposes. Who's watching the watchman? So quite often it pops up in modules saying, hey, it's great, we got all these superpowers that our administrators can do. Who's making sure the administrator isn't doing nefarious things? So that's one of the reasons for auditing. What methods have you used for auditing? Again, we saw back in Server 2012 how we turn on auditing for file access, right? When we modified the firewall on your laptops that time, it started generating logs whenever somebody failed to log into your laptop. So there's a few examples of what we have done before. What are the limitations for the methods you've used? Well, for the laptop one, it wasn't a unified source. So all of our logs were just on your laptop. Yes, we could have set up a syslog server and pushed your laptop data right to a centralized resource. But quite often with logging, the issues are either A, they're limited in scope to where they are. B, it's a one-off that you're doing in a work group type scenario versus at an enterprise level. When we did do some of the auditing features in Server 2012 with Active Directory and group policy did give us the ability, if we wanted to push out that policy to everybody, which means everybody would be governed by it. So there are limitations. Same thing with SQL. There's certain things you can do, but you have to keep in mind a variety of things such as access and real-time considerations, right, and data location. What standards does your organization use? Okay, so I'm not aware of any specific governmental standards like ISO this or ISO that, but I do know that we are governed by the Ministry of Education to keep personal information secure. That is imparted in part by security groups and access right to certain folders corporately. There's a folder in Willis that's the admin folder, and by admin they mean administration, right? So people like Harry and Nicole, right, and Dan, and I guess Cindy as well, access that data, especially when new students enroll. But by default, I don't belong to that security group. So if I was to go there, I get bounced. Of course, as a domain administrator, I could add myself to that group. Hence the reason for auditing, right? Who's watching the watchman? Of course, I'd never do that. That's on tape. I'd never do that. So part of the compliance, the text mentions the concept of the common criteria compliance, right? So C cubed, which supersedes the previous C2 rating. Again, it's an international ISO standard, which means that it's something that, if various countries say, yes, we follow this particular standard, right? Then therefore they can say, okay, great, you are keeping your data within this realm of compliance. So therefore, if we use you in our supply chain, we can tell our customers that, yeah, our stuff is still good and still secure because these other guys that we use follow that as well, right? One of the issues in our global economy and getting widgets from company X or data from company Y to run our business is that we could be nicely locked down and buttoned down, but if we hand data off to somebody where it's the Wild West, then all the security that we've done is just potentially exposed our customers to vulnerabilities. So it's important to have these compliance standards so that people can link together their efforts. By default, it's not there, not enabled. You can enable it by accessing that stored procedure. Author should tell us in his text that you only get this fancy feature if you have the enterprise version. So it's another one of these scenarios is that's why you're buying enterprise, because if you want a full functionality, right, including this ability to be compliant. There's some other sub features in here. So the residual information protection, right? So RIP. The idea with that, so recall way back day one when I was drawing goofy pictures on the tablet and I was showing you how the data exists on the hard drive, and then when somebody or something wants to pull records from a file, it actually pulls it from that into memory, and it lives in memory inside these page files, and all the transactions happen to the copy in memory. And then when the changes are done to that, that gets committed to the actual database file on the hard drive again. Well, there's a moment and several moments where the data is actually sitting in memory. This RIP will go over and wipe out any of the page files that lived in memory, so that, for example, if there's a malicious program that's scanning through memory looking for chunks, they will not see the original data that was sitting there. They will just basically see a pattern, right? An overwrite pattern of zeros and ones that is meaningless. So this residual information protection policy allows you to wipe the data so it doesn't sit in memory and is vulnerable. You can look at login stats. So who logged in, 100 failures to try to log into my SQL database at 3 o'clock in the morning, right? So there's a standard possibility that somebody is obviously trying to hack into your database. So log stats. With the common criteria compliance, remember we talked about granting column access. So this is several modules ago. So you could deny somebody permission to see, the inventory table, the whole table, then later on come back and say, I will grant Bob access to the product number column inside the inventory table. Well, without common criteria compliance enabled, that would work. So that's a way to circumvent full-on deny of a table. Here with common criteria compliance on, that won't happen. And if you need to elevate the level, there's various levels of assurance for compliance and security. There are other scripts that you can run that will configure your SQL database environment to comply with that. Okay, so the key part of this, how does it track these events? How does it know when a certain operation is happening? It is a concept of triggers. Then there's a few flavors of triggers. So there's the DML, right? So like data manipulation type things. These fire off when somebody or something does an insert or an update or a delete against something that you're watching. Then there's logon triggers. So something's trying to log on. Those can fire off when that event occurs. And then there's DDL, right? So those are for large scale things such as dropping an entire table, right? So remember, drop is the SQL equivalent of delete. Alter an object, blow away all objects. So there's individual things trying to happen, global things trying to happen at the DLL level, and then logons. This is all great, but there are issues, there are limitations. So if you are going to sit there and watch these events, and you're looking for it, or your code's watching for it, or the database is watching for it, and then it happens and says, okay, I got to do something. Well, you are doing that logging activity, that auditing, right, before you actually retrieve the data and deliver it to the user. Something is trying to access the data because somebody needs it for an application they're running. So you're providing security on top of it, and now you're slowing down response. Administrators, sufficiently powerful users, can turn off triggers. So that's great. We got the security thing in place. Our DB administrator for the whole database logs on to the machine, and he's gone postal, and he goes and shuts off all the triggers and then goes through and starts deleting stuff. So it didn't work. There are certain SQL commands that you can use. So remember the select command, right? Where you're picking things from a table or from a database. This version of triggers can't detect when somebody's just doing a select. Remember, a select is basically saying, let me potentially have access to this table. That flies under the radar. And since triggers watch for certain events, right, and they may log something and they may have an action, or you could have a complex set of triggers that, if somebody goes to delete a table, that may fire off several things. So now you have to figure out, okay, this trigger goes off, then that trigger. So you have to organize your sequence of events. There is a possibility that if you have triggers that start locking down access to data because it's detected some kind of unwanted event happening, that you could actually lock down the entire SQL Server database for everybody because you have a couple triggers sitting there waiting, and X is waiting for Y, Y is waiting for X. They're both sitting there. Oops, I got these things out of order, and then nobody can do anything until this gets resolved. So you have to manage the order. You can manage the order of triggers through the GUI, but you can also use a built-in SQL command to specify the trigger orders. There's a chunk of code that's in the middle of page 4. And maybe I'll change my share, because I think I will. Top share, big share. Bear with me. So here's making a trigger. So making a trigger, there is a bunch of SQL coding that has to go on. So yeah, it's a great feature, but it's not quick and dirty. But it does give you the ability to create, customize, actions and reactions, right? So for example, this is a trigger that's being made. It's being called trigger employee salary update, and it's basically using the database object of employee. So it's looking at the employee table, and if an update happens, right, then here's a bunch of code, and here's basically saying, oh, if the salary is changed, right, then we're going to insert information, right, track this, and we're going to keep track of what the old salary was, what the new salary was, who was updated by, what time was updated at, and they're going to basically insert that into a secondary table, right? Again, it combines the information from these two sources, the old and the new. One of the part about triggers is that if you want to keep track of who did what, so for example, here it says updated by, so that would tell you the name of the user that did it. Your table has to have a field called exactly this, S username, and if it's in your table as a field or a column, then you can actually use it to pull out who's touching it at the time, so you can store the information away. So yeah, great ability to trigger and something happens, but there's a lot of programming involved. There are other options besides using these triggers to do it, and we're going to start talking about that in a second. Share PowerPoint. Okay, and one of these options is using the temporal table. So that trigger code I showed you, it was figuring out where the data goes and on what events. With a temporal table, you can say, if a change is happening on this particular thing I am auditing and watching, slap the changes into this other table, because that way I can go back and say, okay, who changed what when? And oh, here's the old value. So you can undo the change and restore the data if it was an inappropriate change. So it automatically records the to from dates, right, of records in the database as they're changed, and it becomes part of the table definition, so no additional code required. So you don't have to go and figure out all that SQL code you saw in the textbook I just showed you. You just basically say, I'm making a table. I want you to have a temporal table associated. Here's where you put stuff, and now the table is basically looking after itself. If it keys on those triggers that you said, please audit, it will put the data in the temporal table, right, the history table. Some limitations, you still can't see select statements. So if somebody just says select table, they haven't done anything to it yet, they just said, I want to use this table, that flies under the radar. All the events, insert, update, delete, everything, you can't have custom ways that they behave, so they all get audited and recorded in the same way. The table that you're writing to, the history table, has to live inside the same database as the table that's being manipulated. So that's a limitation in the fact that if somebody's hacked into your system and they're munching through tables and you're madly logging the fact that somebody's doing something nefarious, since that table's in the same database as the guy is manipulating, if he can find the history table, he can nuke that too, and there goes your logs, right? He's covered his tracks. Right, and as I said, if you want to track usernames, then you have to make sure that the table that you have has a column called suser, sname. So even though you've created the table and say it's a table of just products that your company has, and you don't care about having a system username in there, if you suddenly decide you want to audit that table with temporal tables, you got to go back and change your definition, and maybe on the end add this S user S name. So you have to, if you want to track who touched it, go back and change your original table definition. All right. Excuse me. Get where I'm supposed to be. All right. Stop this share. Oh, there's better. New share. All right, you should be able to see my SQL machine now.
Yep.
Okay, thank you.
Indeed.
Indeed. Oh yeah. Before I jump into this demo, there's something I wanted to show you, and it may be useful in the future. Throughout this particular chapter, they talk about, oh, and by the way, if you want to see all the certain audit actions, blah, 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 go to the following system table, and they're there. And you may think, okay, great, thanks. How do I do that? Here's how you do that. So inside, yeah, there's lots of stuff. So as I mentioned before, right, SQL has its own tables and its own databases that it keeps track of stuff, and we keep talking about the master database as being the central, metadata repository. So if you want to look at, for example, the this information for audits, etc., inside your Object Explorer, if you open up databases and open up system databases and go inside the master database, there's a subsection called views. And I told you before, views are basically a filter on data that's in a particular database. There's a whole bunch of them. Okay. And the textbook talks about looking at, which one was this? Scroll. Right. Sys DM audit actions. Okay. So you scroll down here and you look for Sys DM. They're alphabetical, right? Audit actions. So this is the table that's keeping track of the possible auditing features. This is a topic that shows up later in this module. But in the future, if you want to look at system tables, if you can find the view, you can actually right-click it and say, select top 1,000 rows. So what that does is actually generate this SQL code that pops up over here. It runs it, and then it displays the results. So if you wanted to look at the contents of a table, right, you don't have to go and manually type all this stuff yourself. You can go here, find it, right-click, select top 1,000 rows, bam, and it's basically showing you here all the stuff that's in that audit table, right? And there's grant with revoke, part of the schema. If you decide that 1,000 isn't enough, right, then you can go back here and change this number. Okay, so this is a quick and dirty way for you to dig inside of some of the system tables inside the master database to look at them and see what's going on. All right, so hang on, make it a little bit bigger. I'm gonna move you guys. Okay, and demo one. All right, so this one is about temporal tables. So having auditing events go to a table. For example, here we've got a table called DBO Manager. Great. I don't think I ran this already. I could have, knowing me. And I told it that the history table it's going to go to is going to be DBO.manager history. So as I said before, having a temporal table, you do this at time of creation. So we're telling this table, here you go, I want you to manage it. Okay. So this should basically complain and say the table is already there. All right, so great. So it was made before, it's fine. I'm gonna make this a little bit smaller because you don't need to see that much anymore. That's better. And I'll drag this down. So the idea here is that this should now be a self-monitoring table that if things change. This next chunk of code is going to change things. It's going to insert some data into it. Okay, it's because I already did this. So it would have inserted it, but because this data was already in there, it's redundant. So I complained about that. Want to update something. Okay, even though this is there, it should still be okay to update it. All right. So in theory, it went through and it set the password for the administrator. So we're looking after this. Since we are making password changes, somebody changing the password, that sounds like might be a security thing. So therefore, let's monitor it. So let's see what we've got in here for the original manager table we made and the corresponding manager history table that we told the manager table when we made it, please record any of your changes in there. So, okay. So there's the table, right? And there's the history. So again, these guys were already in there. That's why you saw the error message down here. This is basically tracking the fact that there was a change that occurred to the administrator and there was a password change changed by AdventureWorks students. Change from, right? So there's a timestamp on it, etc. Right? So now we've got both the original table and its history table, and as things are changing the original table, the history table is keeping track of it. And the benefit from this, again, is that you didn't have to go and learn all that SQL code to create your own triggers. At the time of creation of this table, you said, please track following changes and put it in this history table. Okay. Now we queried. Okay. And we're seeing the data, basically a combination from both tables. We're looking at DBO manager table, right? And then also the changes that happened historically, who did what when. Sorry about the pauses while I drag. Okay, so this is going to go through and look at the manager history table, looking for a manager ID of 1, and go and pull the data back from the manager. So it's basically trying to find somebody changed the thing with the ID of 1. Let's go back to the original table, right, and tell me what the data was and is. And again, the key thing here is this encrypted hash of a password that we're changing. If this history table is being used for auditing, then it's a good idea to not let people directly access this history table and whack it. So therefore, this is going to show you that you can't go and actually change the history table. And they decided to call the person that's doing this malicious user. Okay, so that's good. The non-editing of the history table seems to be working. But if somebody is of sufficiently high level, right, they can mess with the data and insert, malicious information or misleading or false information. Right, so it worked. And I'm going to look at the underlying chunks that are involved here. So it's a bit of a deja vu again. Come on, drag bar. Right. So there is the hacked by malicious user. So we still have a record of what happened, but the temporal table was actually manipulated. And we're cleaning house. Last time I did this, I probably should have ran that to clean up after myself. Okay. Right. So got rid of the table, got rid of the manager history temporal table. New share. Let me move back to the PowerPoint. over here. All right, so there's more. There's a concept of extended events, and this is the concept that's going to show up in Module 12, and when we continue the conversation, we'll talk about that. Similar in nature to triggers that we talked about before, but it is a organized package of things that you can do where you can create what you're looking at, what do you want it to do, where you want the data to go, and then you can take these events that you have and targets and link them together in various fashions. So it allows you to create basically building blocks of stuff you want to watch and where you want it to go and things you want to do and mix and match. We're going to talk about server audit levels, creating a server audit, defining it, audit actions and audit groups. The good news is that there's a bunch of default actions and groups that you get for free. So there's a bunch of things right out of the box you can start applying. You can create your own custom ones to meet your business requirements, as the author says. You can audit the server, you can audit the database, right? So you can look at the whole box, you can look at an instance, and now you can start just looking at particular databases inside of it. There are dynamic management views and system views. In later modules, and in particular Module 12, the author starts using the acronym DMV, and at no point does he define what the heck that means. Okay, and that drives me crazy when somebody does that. An acronym shows up, the first time it shows up in text should be fully spelled out. It stands for Dynamic Management Views. It shows up here. Yes, you can do it in Azure, and as always, you can't do everything because you're on Microsoft's physical server, so they'll let you do database stuff, but they're not going to let you mess with the actual server box. Using server audits, creating your own custom ones, right? And then a demo and another demo and another demo. So extended events, it lets you create your own framework for monitoring. It's event driven. So what are you doing? You're watching for certain things to happen, logons, data changes. Good news is that you can use extended events to catch selects. So the previous auditing features, remember I said select statements went under the radar? With this, you can actually watch them and catch those as well. And it's general purpose because you can create a set of events, say like an action group that's all about backup things are happening. You just use that one right out of the box and say, I want to watch all backups for this server, bam. I want to watch all backups, not for the whole server, just for this database, bam. Now, anything that could involve backup, restore, right, etc., will be covered and audited, so you don't have to build them all from scratch. And it's based upon this concept of extended events. What is that? So an event is something that's happening. So the triggers we talked about before, that trigger code that was firing because some kind of event happened, right? So the event is the thing that's happening, like a logon. Target. Where do you want to put the data? You have a few options. You can write the data to a binary file somewhere on your server locally. You can write the data to a binary file somewhere on a file server elsewhere in your network. You can write the data for the event, right? The target could be your event viewer. You can write it in the application or the security log inside the built-in event viewer inside of Windows. It's kind of handy. You can take an action. Now, the action is not, hey, go trigger this or go fire up this backup job. An action is something else you can do with the data that you've just intercepted or the information that you've just intercepted because this event fired off. One of the things you can do is keep count. So you could have an event that's watching for logons or failed logons, and the target is failed login. Let's stuff that in the application database in the event viewer, and your action could be, +1. So there's 100 failed logons. You go back and look at this overall event that you just created, this extended event, and your action counter is saying, yeah, there's been 100 of these. These events will remember the fact that it's happened 100 times. And then maybe when that happens, you decide to take another step. So once 100 failed login attempts happen, you fire off some kind of security code that goes and finds the IP address for the TCP connection that's doing this, and you drop that. So this action stuff is not the action of dropping the connection. This action stuff is what you can do to the data. Counter +1, counter +1. Predicate, things that have to be in place before you take this action. So you're effectively reaching out and looking at other system values and database values, right? Other type event information that you want to use to better define what you want to do and when it should happen. And then type and mapping information, filters effectively for the overall event. And then a session is a way to bundle these things all up together. So you have these reusable modules, and we're going to talk more about session details when we get to chapter 12, module 12. But sessions let you take your events, your actions, your predicates, right? Bundle them all together. And now you have these larger general purpose items you can apply to your systems. What can we audit? So you can audit server level activities, and you get this in all versions of SQL Server, so you don't have to pay for the enterprise one. Database level audits. So I want to look at the AdventureWorks database. That's all I care about. Don't bother auditing anything else that's on this server. That comes with the following additions, right? Enterprise Developer Evaluation gives it to you. And then some of the terms involved. So server audit, basically where to store the audit data. What physical server is it going on? The server audit specification. So you make the spec, it's going to basically give you the definitions for different server level action groups, right? Again, this is extended events. So you're making these events in all bits and pieces. And then the database one is database level. So you're monitoring the AdventureWorks, right? What's the specifications for what I am looking at for the AdventureWorks database, right? So actions, collecting extra data, right? Can raise events, right? If you had a threshold that you're looking, for example, right? Again, this is one of the ways you can now catch the select statement that people might use or things might use that you couldn't catch before with the other versions of auditing. Action groups, so now a complete collection of events that you want to monitor. And the author says, for example, the backup restore group, if anybody's doing a backup or restore operation on this particular database, the extended events will fire off, right? And then possibly right to the target, right? And the target location is where you want this data stored, in a file, right? Or inside possibly one of the event logs that's built into Windows. So to create a server level audit, you need a target. You need to know where the data goes. If this thing happens, where am I storing it? A queue delay. So you have a SQL server because you have data on it that people need and your systems need. So that's important. You're turning auditing on because you want to add some extra security. You may have to accept an allowable delay before your logs get written because you need to let people and things access the data so the business runs smoothly. Meanwhile, you're going to buffer things up in the queue, and when it's a good time for you to write your logs, you'll go write the logs, and that way people can still keep working. So you can pick and choose a queue delay, right, in milliseconds. So this is a tunable activity, right? If you turn on auditing and suddenly everybody starts complaining, right, about how slow things got, you're going to come back and start tuning this queue delay, and then therefore people say, yeah, okay, things are running good now. Now, if you can't log, what do? So that's the on failure. One of your options would be to shut down the server. I am auditing failed logons. Oh, I can no longer audit failed logons. Shut down server, right? Disable database. You could also fail open, as they say, which means, oh, I can't do that? Okay, I can't do that. I'll send an alert that says I can't do that anymore, and just let people keep running, right? Of course, shutting down and shutting things off, right, will protect the system. If the reason you can't audit logons is because the hacker has got in far enough that he shut it off. Also recall that turning on these auditing things is a who's watching the watchman type scenario. So if your new database administrator, the new guy, the co-op student, comes in and decides to be malicious and turns off the audit logs, and all of a sudden server goes down. What happened, right? There's a few ways you can do that. Okay, and sort of that's the target where the file's going. So for example, here we've got a security audit. It's going to store it to this location. The location is a folder, because inside that folder there'll be multiple log files created. So if a log file gets full, it'll create a new one. So again, your file path for these targets, if it's a file, is not the actual file name, it's a folder. It's going to create files inside that folder. You can create maximum size, so you can determine every audit can only blam this much data into my log. 0 means I don't care, let it rip. You can reserve extra disk space if you're worried about your that location or that entire drive getting full. And we will roll over the log files when they get to this big, right? So it's circular, so you can determine how often you roll over. Here's our queue delay. So we're going to wait 1,000 milliseconds, which means a second. And if I can't log, then I won't let that thing that just tried to happen function. So I will not allow. So if you are tracing selects, for example, if you can't write to the log that so-and-so just selected the table, their select will fail, which means they can't select the table, which means you effectively locked everybody out of that table until you resolve why you're no longer logging it. Again, always a trade-off, right? Security versus access. And you can, don't forget, when you create these things, you can turn them on and turn them off. So, and auditing may be a troubleshooting thing you do. Maybe you don't always log something. You don't always have an extended event turned on for something. And you don't do that because it sucks up too much CPU time. When something seems to be going sideways, then you go over and you'll turn the state to on, and then it starts logging. When you're done your troubleshooting and you figure out what's going on, then maybe you go back and you turn the state to off. So you got a toggle switch for these. Okay, and for convenience, I mentioned before, you can have pre-existing action groups. You can create your own custom action groups. There's those that operate at the full-on server level, those that happen at the database level, and those that are action groups that happen inside your audit process yourself. So things such as looking for a select statement. I said before, there's a bunch of predefined action groups. So there could be the successful login group as opposed to the failed login group. And maybe you want to keep track of who's touching a database. So successful login group, Bob from marketing or whatever, the marketing security group opened the table up, it's business as usual. So you're just keeping a track of who's in there doing what. That would not usually mean you're tracking something malicious. It's just mean you're double checking to see who's been in there doing what. Actions at the database level, and the actions and the groups, right, are linked to a particular audit. So you create your extended event audit, and you're saying, to this particular event, I want the following action groups. So you could, in theory, create an audit that is, DBA admin audit, and at first it has nothing associated with it, and then you can go back later and say, I want to link the backup restore group to that audit, and now you're auditing potentially any of the DBA admins that are doing backups. You may say, oh, I also want to audit anytime a DBA guy successfully logs in, so you can go back and link the successful login group action group to it. So you can go back and link these things to it and basically add capabilities or things that you're watching to the audit by name that you've already created. So this is where I said that this is a building block type scenario. You can create the things you're watching, create the things you want to watch, create the targets where you want the data to go to, and come back and, as you choose, dynamically change what these are. So for server level, you define the audit, you specify the action groups to be included in the state. So here you go. You create an audit and you called it audit logins. You're going to do it at the server level, and to it you link the failed login group and the successful login group, and you turn the state to on. So now you have this audit entity that you can apply to various places, and it's going to by default track these two things for you, and it's on, which means it's currently active. Go back later, turn it off, and now it's no longer sucking up resources, and of course it's not effectively tracking and auditing. Database level, again, you're creating the audit itself, the action groups. You can specify actions on specific securable objects. Right? What do they mean? Remember, a securable object would be like a database inside of there. There's also the principals. So what particular user or user group am I watching in the current state? So in this example here, we are creating a database audit, right? Calling it DB security, right? Putting in the server security audit section. We're going to add this predefined one, database principal change group, and we're going to reach inside and we're going to pick the human resources database, and we're going to keep track of any time that somebody's that is a member of the DB_data reader group, and we're going to log that. So it's effectively anytime somebody who has permission to read that database does so, it's going to create a log. So this is a track of who is touching it and potentially who's the last person that touched it. And it's not necessarily just people, right? Remember, applications are people too. So maybe the scenario is database got clobbered. You want to figure out how it got clobbered. You go and check your audit information, and you see that the programmer guy wrote a new program, and his program came in and deleted all the records, because the program application would also be a principal, and that principal would be caught potentially inside this DB_data reader watch. Yeah, and at the beginning of this module, I pulled you over to these tables. So again, here's the system tables, right? So this keeps track of a variety of items that are useful. So this one's going to have every single available audit action in all the audit groups inside this one. Again, this one has some class and type information, right? So basically it's mapping codes. Again, this is more interesting if you're programming things. And what's the overall status? So all the audits that are defined on the particular SQL Server instance and their current status, right? And status often means state. Is it on? Is it off? More information you can look at. Right, so this one here, all the server level audits. This one here, all the audits that are writing to a file type target. So things that are going to a folder somewhere that aren't being pushed off to the event viewer. Specification, details, database, etc. So if you need to take a look at what is the current state of various audits, what's being watched on this particular machine or this database, where is the data going, right? Because it could be going anywhere. You can wander through these tables, look at the content, and it'll give you a peek under the hood as to what's going on and where things are going. And yes, you can make audits inside of Azure through the Azure portal or using PowerShell commandlets in the virtual environment. You can't do the server. Right? As I said before, it's Microsoft Server, so they're not going to let you slow it down by watching it. So therefore, you basically can only audit your own databases. Success and failure. You can create SQL to do it, right? You can use more advanced SQL that are pulling parameters from the Azure environment. You can audit it by calling a stored procedure inside the database, right? You can audit logins, and you can handle, record any transaction management that's going between your different database objects. And all the logs are being written to storage tables. So obviously, Microsoft would not want you stuffing your audit logs inside their event viewer on their server. So this goes to a targeted stored table location. How are we for time? We're doing good. Okay, I'll switch over in a second once I've got my stuff together. Blah, blah, blah. All right, so I got my solution set. Slide you guys over here. Go to query. All right. New share. SQL machine. Clickety click. All right, on the SQL machine. So I've got another chunk of code here that has some of our nicely predefined SQL for us to mess with stuff. So we're going to create a new audit. Right. So we name it MySQL audit to file. So here's where the logs are going to go to, right? Inside this folder. Queue delay, right? So 5 seconds. So we're allowing 5 seconds of data to be buffered up before it has to be written. Okay, it didn't complain. We've made it. Now we're going to turn it on. So here's where you can toggle the state to on. You can come back later and turn it off if you wanted to. Go. Get this a little bit smaller. Right. So now we're going to make something that's at the server level. So that's where this chunk goes. Right. It's going to be a server audit. We've associated that audit with the MySQL audit thing we just made above. We're going to call it audit logins, and we're going to make use of the default groups. So we're going to watch for failed and successful ones. And while we're at it, we're going to turn this thing on. Didn't complain. Okay, and now we're going to create a database one, and we're concerned about what's happening in Sales App 1. Again, we're creating it. We're associating it with our higher level audit that we created. And we're going to look at insert and update events on the database sale app by public. So if anybody who's identified by public, which if you recall, public basically means unauthenticated users, it's going to trigger on that. Anybody in public that tries to select the schema and any kind of schema object change, right, is going to be tracked. And we've already told it where to put the data because that's what we did up here. So this thing, right, specifies the audit and where the logs go. This chunk here says, what are we watching for? So where it's going to get logged was back where we did it at the very first step. Now you want to add some more stuff to it. So you can go back and alter it. And recall that alter is the SQL command for change. So we're going to go back here and turn that off. Right, so that's what the state with off would do. And we're going to go back and modify this one, and we're going to add to it the schema object permission change group. So guess that wasn't enough, just having this here. We also want to track in case anybody starts toggling permissions. I hear a munchkin, and it's being recorded on my video, and I don't pay royalties. Okay. So what do we got here? Select from bang audits. So we just pulled from our table. So that's the one we made. Sorry, let's see where it stopped. This would be a lot more enjoyable to, well, arguably, this would be easier to look at if I had a bigger screen. So I'm sorry, guys, but this is basically telling you what kind of information we have inside the system data. So I had showed you this before at the beginning. Remember, I went to this sysdm audit actions, right, and showed you the whole table. This particular query is pulling the metadata from inside there to tell you what you've got. So we've got an audit logins thing, and the action groups that are associated with it are the failed login group and the successful login group. So again, if you need to go back and see what the heck's going on with auditing, right, on this whole server, you can go back to the original sys tables that are inside the master database and take a peek. Pardon me. So let's see what's inside the audit specifications, right? So the specifications was basically saying, what are we looking at, right? What kind of events? So the database that we care about here, right? We're looking after the sales app one database, and the types of things that we're going to look after will be, we added this one on, right? The schema object permission change group. We added that before, the schema object change group. In our definition, we said look for inserts, look for updates, look for selects. So again, if you're trying to figure out what an audit is doing, you can dig into these low-level system tables. And we didn't do much to prove this was doing something, but we're going to get rid of it now because, as was said before, having audits kicking around sucks up CPU resources. So if you were turning this on, just do a temporary test. You could run all this to clean house afterwards. Man, wiped. We're doing pretty good. New share. Meanwhile, back at the PowerPoint. Slide you guys over here. So I mentioned before, you can use all the default ones that come for free when you install things, right? Or you can start creating your own custom ones. And here's where the trigger conversation that we talked about at the beginning of the module shows back up again. You want something custom? Guess what? You're going to do some SQL programming. So for example, user-defined audit group. And again, you can create these from the GUI, right? Or you can create them using the SQL code itself. So here's a chunk of SQL that's going to add a trigger inside there that's going to double check when something happens to the employee bonus part of the human resources table. And effectively, it's going to select here and track whenever a bonus is greater than $1,000. So you can associate this trigger code with your audit. And now you are specifically looking for not just somebody changed data or added data or logged in or deleted stuff, but you're watching for anything that, in this case, exceeds over $1,000 bonus. I guess that implies that bonuses greater than $1,000 are an unusual event, and therefore it'd be great to track those just in case the payroll guy likes to give himself $10,000 bonuses on a regular basis.
Every week is normal, right?
Well, if you're holding the bags of money, right, what are you going to do with it? Career change. I should have taken accounting. Exactly. I should have taken accounting. Career change. Silly me. All right. So I guess I'm showing you a custom audit. Yeah, I need 3 screens.
It's almost riot time.
Yeah. Okay. Excuse me. Okay. So here's another chunk of nicely predefined SQL for us. So we want to create an audit, right? And a custom audit. Well, we got to make the audit first. So again, this is similar to what we did before. Creating an audit, we're calling it custom audit. We need to tell it where to stick the audit information. So basically slam it into this folder. How long can we buffer things up? 5 seconds. And let's turn the state on so that this thing will actually be active. It hasn't got any content in it yet, but it's potentially active. Okay, so now pointing back to that audit we made, we're going to tell it, guess what? We want you to enable, right, and use the user-defined audit group, action group, which means with that in place, now we can tag some trigger code into this, and that trigger code will look after, whatever we're monitoring. In the textbook, it was bonus changes, right? Okay, the exec command in SQL is execute, so it means run the following function. So there is a function, sp_audit write, and we're going to call it directly, and we're going to tell it to throw the following information in here. So events are tracked and tagged with event IDs. So this one was decided to be tagged with 999. We're going to set succeeded to 1. Remember, 1 means true, 1 means on, 1 means success, 0 is false, 0 means off, 0 means failed. Okay. And so now, did that actually get tagged? So this is going to go and pull in our file, right? So there's the folder it went to. The files that are created are going to be custom audit, right? And it's a wildcard character. So again, if the log file needs another log file to be created because the log file is getting full, there could be a bunch in that folder. So this is going to go through, open that up, and try to pull entries in from it that have the event ID of 999, which is what we wrote here. Okay, so now we just created that custom audit that was watching for that particular call. We had it happen, it wrote to our file. Okay, so basically we used the sales app 1. So it effectively activated and used this event that we created in the corresponding code. But wait, there's more. 5, I know we said it long, and there we go. Okay, let this fire. Bam. All right. So we created a stored procedure inside of sales app. So we just made a function, and this is what it's called. So we call it USP. So I guess it tells us user stored procedure. Order detail discount. All right, if discount is greater than 0.3, okay, so I guess if a discount's greater than 30%, it's worried about that. So again, now I guess you're keeping the sales guys from selling themselves stuff for a 99% discount, and then reselling it on eBay for profit. Okay, and it's going to link together the order number ID and the product and the discount, and it's going to write that to our log file, and it's going to tag it as a 998. Okay, so basically now we've created a new stored procedure that will keep track of anything that we decide is unusual for a discount level in that table. Okay, and that's going to call our built-in procedure. And the first time we're calling it, we're saying it's a 5% discount, and that's less than 30%, so that shouldn't be weird. The next time we call it, we're telling it that it's a 45% discount. So that should be weird, which means it should be logged. And let's see what happened. So again, we're reaching out to our log tables and we're looking for an event of 998. So, and that's what we tagged for this particular watching for weird discounts. Okay, and there you go. So this auditing event log, with a little custom procedure, it's watching for exactly what we think is important, right? It's not a general level thing. And it basically just tagged order 10248, product 42, right? So product 42 is probably a, big TV, discount of 45%. So we just tagged and tracked that. And we're cleaning up after ourselves. We're getting rid of that so we don't have these audits sitting around slowing down the machine. New share. Meanwhile, back to the PowerPoint. Let's see where we're at. Move you over here. All right, so we have some audit data. How do we retrieve it? Well, we kind of just did it there in the demo, right? By hand, by reaching into the file and displaying it there. But there's other options. Working with the audit record structure. When you turn auditing on, what could some of the issues be? And okay, I guess another demo of viewing the output from an audit. So if you choose to use the target of the event viewer logs, then you can push your log records into the event viewer, and then you can use the event viewer to look at it. So it gives you a default GUI. So instead of having to go and create your own SQL and look at it through the Management Studio, just go to the good old Windows event viewer and see what you got. Recalling that the event viewer allows you to create filters. The event viewer log is a haystack of everything that's going on. So you could use some of the custom filters to look for event IDs that map what you have put into it. The other option too is that you can write them as binary files to any target location. And if you want to pull in the binary file and look at its content, there is a system function, right? And it assumes that you're pulling in a binary, and you can use, again, you're creating your own SQL code here. Select star. Remember, star means select everything. So every single column, all the data that's in this thing, right? And in this case, here's another wild card. So it looks like we've been targeting our files to go to our X drive inside of a folder called audit files. This star means do every single file in there one at a time. And then we have some defaults. They're going to make some assumptions about the format, and it'll display to you what the content is. So you have that as an option. Where'd I go? All right, so this function, right, is going to return you data. So if you get the data back, and you can create some of your own SQL custom code, you can pick and choose which fields inside that record that comes back. So you can build your own table, build your own queries, pull those queries and display them on a form somewhere. So you can do it just as you would with other SQL issues. If you are putting things into the event viewer, which is an option, so that SQL doesn't break the event viewer, so it works by default, it is complying that anything that's bigger than 4,000 characters gets broken into multiple audit records. So if you are logging something that has 8,000 characters, you're going to get 2 log entries inside the event viewer for that one log event that you created. You can use the sequence number that's there, right? That basically shows you which of those multiple records actually belong together. So the sequence number column indicates this is chunk 1, this is chunk 2, this is chunk 3. So you have your auditing system in place, right? What are some of the things you need to think about? Well, I already showed you, right? You can turn them on, turn them off. So therefore, if all your audits are turned off, you're not auditing squat, which means you're not going to catch the failed logins. right? If they're all turned on, then you're logging everything, and maybe you don't mean that. So you have to successfully manage the state of all your audits. If you have a multiple server type scenario, if you're moving databases around, recall that a lot of things are referred to, not by their actual name, but by some globally unique identifier, right? The GUID, gobbledygook string. Those are different across servers, across databases. So if you are removing things, restoring things, you might restore a bunch of definitions that have GUIDs that don't map the GUIDs of the things that are on your server. So you may have to go through and modify and update and reflect the changes in that. Same thing in mirrored scenarios. If you're mirroring servers across, the GUIDs could be mismatched. The GUIDs have to match on a server audit level, and you can create the server audit and give it the GUID. So if you make it on server 1 and you want the exact same thing on 2, 3, and 4, when you go to create the audit on servers 2, 3, and 4, instead of letting it default create whatever the frig it wants, you can use the GUID value and say, use this one. And now they all have the same GUID and they're all linked together. Being able to, when you're auditing, you're writing to the database. When you're doing normal work, you're writing to the database. So overall performance, right, is going to be impacted. If you decided that if this audit is no longer working, then don't let the SQL Server run. So the example I gave before was if you're auditing all failed logons and suddenly you can't log that anymore, then you decide, let's shut down the server. Well, then it's just shut you down. You can use a different configuration switch that will allow you to actually start the instance and change that. Because if it shuts down the server, then you can't get into the database to look at your logs. So manually, from an admin perspective, you might have to loop back in to get into it. If you go and restore a database, and inside that database, there is no record or doesn't match something that it knows about, then it ignores that audit. So this is another one of those scenarios that if you are restoring something and GUIDs don't match, they won't work. So you could accidentally restore something, think that you have all these audits configured, and none of them are actually triggering because the server does not even recognize that identifier. Okay, I'll switch over in a second. Do this demo, then we'll do a break. Share. All right, so more SQL script. So we're going to create an audit and we're going to give it a target. So we're calling it file audit. It's going to be written to this folder location in red. Now we're going to turn the state on. Now we're going to track something, and we're deciding we're going to actually put it inside the application log, right? So we're doing one of those, let's put our data right inside event viewer scenarios. How much you got here? Okay, so we're going to, again, using our sales app1 database, we're going to associate those with that file audit, audit entity we created at the top. And again, we're checking to see if anybody who's unauthenticated, right, that's part of the public group, is selecting schema, right, in sales. All right, so we're tagging the same activity in both of these audit events. So we're going to fire up this one. So basically it's going to select information from the sales customers. So here we go. So this has pulled some of the data. Okay, now this is a bit of SQL gobbledygook, but we're going to go in and now reach into our audit folder, pull in everything, right, and display what we've got. Okay, so AdventureWorks students, because we ran that previous chunk of code, right, met our criteria, and this is all the stuff that's being logged. All right, here's the server instance name, here's the database name, what did it touch, customers, what did it do, selected top 10, etc. Right, where'd the audit go to? So this information is basically telling us, here's what happened to what, and for greater details, if you want to look at the entire binary, right, here's its location. Event viewer. Oh wait, event viewer. Already got it open. What time is it? 4:36. Really? So let's go to security. Let's go to applications log. All right, so that's timestamp. Okay, so here's one of our audits. This one here, right, so this is the event viewer application one. So that's basically saying that we had access to the particular schema that we're looking at. Classic audit success. Get the details. Friendly view. I don't know what else it's going to show. Oh, maximize. Maximize. There you go. AdventureWorks student, etc. Right? Target principal name, SQL audit data session. Okay. So the event got written to the binary file in our folder, but it's also being written here into the application log. So you can go and look at it here like we just did. See things, oops, come back to me. All right, and then the last step, we're cleaning up after ourselves. The programmer reminds us here that, remember, you got to disable these things before you can drop it, right? So it's one of those standard SQL things. Before you can delete something, you have to turn it off, right? We'll let you delete things that are potentially currently active. All right. So let's take a 15-minute break.